Hello, everybody. Welcome to our guest lecture. Let me introduce our lecture today. Which is Tomasz Bradecki. He's a designer, lecturer, researcher, PhD architect at the Faculty of Architecture at Silesian University of Technology. Since 2009, he's a lecturer and researcher in the Department of Urban Design and Spatial Planning as associate professor. And since 2019, he's a member of the Silesian Department of the Architecture and Urban Planning Committee of the Polish Academy of Sciences and founder of Urban Model.org. Author, co-author, and editor of several books and several dozen scientific articles in the field of urban planning and architecture in Polish and English. And he is member of the Polish Chamber of Architects, co-owner of Studio VB Architeccy, and designer of single-family houses, housing estates, and public buildings, winner and participant of architectural composites competitions. Stop sharing the other screen. The floor is yours.
Okay, hello everyone. I hope you hear me. As mentioned before, I'm not only an academic teacher, I also design and run my own studio. And the type of my lecture is about eco-architecture. Everyone have heard about eco-architecture, yeah? You probably would join it with, a building which is covered in green and so on. In the recent few years, I had an opportunity to design a few buildings which can be called eco-architecture. And subject of this lecture, eco-architecture opportunities, threats, chances, and so on. I'll just get on. Okay. Now, the first case study is the Center for Environmental Education Center. This is a building designed next to the trash area. So a place where you collect trash, rubbish, you make hills of that and so on. That's the border of the city where I come from, Gliwice, very small city, comparing to Istanbul, very small, 180,000 inhabitants. And this site is the trash site. When they push trash, they change it and so on. And the building was meant to be ecological. It was a building which was meant to be at one part the office space to rule and to manage every process which is getting on the site. And the second part of the building was meant to be a gallery and education center for children to educate people about, segregation, about waste. As you can see in the design, one of the main ideas was to show with the furniture the mark of the turning waste into green, so the circular economy mark. That was a bench, but I'll get to the first idea. So the building is located. Can I just move this? Okay, that would be.
If you click on the bar, see the bar on top on the left. Yeah, that one.
Okay. So the building is located in the immediate vicinity of reclaimed garbage quarters. So what we can see in the background is the garbage actually covered with green. And it turned out that was a challenge. This is the site This is the site where we went for the first time, and the owner, it's a company who is running the all garbage business, told us to design a building somewhere there, but the only thing was that there is a hill of the trash covered with green. That's one of the first hills from the 70s. But you cannot build on the hill because it's garbage, right? So you can build anywhere around. The entire site is a few hectares big. And the form of the building resembles a natural hill, which is analogous to the hill in the background. So the idea was to make a building which goes up. It's slightly similar to the building which you have here. It also going up. But to put the building here, because one of the idea was to make an education route for children, right? So what we did, we decided to make such a kind of building, which as a building is a tool, is a way of education, right? So one of the idea was that a part of the building was to be left open to provide access to the education trail, and the education trail goes up there because behind of that there is an active rubbish hill, another one, where, you know, people operate, machines operate with rubbish. This is very nice because this is green. The second idea was to maintain an education path which goes to the top of the building, right? This is the visual we did for the first time, and of course we wanted to cover it with wood because it looks natural. That's the idea, and so on. So this is the diagram showing what was the way of thinking, how to make the shape. And as you can see, this is the existing hill. So this is the idea of new building, which is coming next to the hill. And the green roof is adapted to pedestrian traffic, and it aims to reclaim HIP. So what we wanted to do actually is to put greenery on the top. And as you can see here, one of the education trails is here on the top, and the second one is here in the back. What you see here is the sheep. Why is the sheep? Because sheep eat grass, and that's a way of cutting the grass on the hill. And actually, they do it, really. So the building itself is a kind of experiment. That is a plan and the idea for the building and the education path. So once you arrive, you will probably park here. This building is mostly designed for children, for classes who would get out of the bus, would go out, would climb up the rooftop, would see the gallery, the building, and then would go here, because from here you get a view for the operating rubbish area, just to understand what it is all about. And that's a kind of 3D axonometrical view showing what we're trying to do. So if we're saying about eco solutions, right, photovoltaics, obvious thing, the skylight, getting light, natural light into the building, yeah, that's of course, car recharging station, that's obvious. One of the idea was heaps for bees to get, you know, more biodiversity, and the educational playground around here. Now, that is a plan in Magnificent. So we also wanted to do some amphitheater thing for the children. Well, I would say that the owner of the company was really brave. He could build, these people could build simple office building, and that's it. Now they wanted to do something extraordinary, and it's really happening. I'll be saying not only about design, I'll be saying about entire building process. And it's not only that you design something. For architect, it might be the finish of your work, but actually it's not. If you go on the side, if you carry on, then you face the other problems. And one of the problems was to make a geology test. And it turned out that about 3 meters below is just garbage, because it was so old. That was garbage put there in the time that nobody really cared about this, in the 60s and so on. So it turned out that most of the soil is not suitable to put the building, even though it's a building which is just 1 story high. And therefore, as you can see, we needed to use filling, which probably here in Istanbul is typical. In Poland, not everywhere, and especially if you put just a 1 story high building, you don't really use that. So the eco solutions, one of the eco solutions was to use the structure which could be reused. And so you've got the structure from the beams from wood, and the metal cover making the roof. As you can see, one of the ideas was the skylight and the green roof, which eliminates heating and absorbs water. But I'm not going to explain only about design. I'll get to the photos because it's being finished now. So that is the technical drawing plan that really we did. And that was the idea for the path. In your career, in your future, probably you will do many drawings which are not going to happen, or even that will be wrong. This drawing, this design turned out to be wrong because the soil here turned out to be not stable to put the path like that. Anyway, you need to try. This is the plan of the building with the main entry and some kind of the central hall. On the left here, you've got the office space, so for the people who manage the entire thing. And on the right, you've got the multimedia room showing different videos for education, different events. And this is the event space and the exhibition space. Elevator views and some other details of making, for example, amphitheater for children, and a try of interior design for the multimedia hall inside. The building is very small. It's not more than 400 square meters big. And a few tastes from a few views from the interior, right? Design. One of the idea was to put a green tree inside to grow, to get the light from the skylight, and so on. I really like that and appreciate that you work with models. In my studio, I always try to force that we do at least 1 model or 2 models. In this case, we did a few. And in education process, I think making a physical model is still something extra than, you know, only 3D. So that was a model we did to convince. I always try to make models in big scale, which is possible to be opened and show a bit of interior layout, right? What we got in 2021 was Barbara, our studio received a prize from Polish Green Building Council, that it's one of the best ecological projects for the commercial for the commercial building, and we were very happy with that because it's being built. At the same time, last year, this is kind of annual report from United Nations Association in Poland, and the project of this building was in that report. They decided that it's good enough. Now, a few slides from the building process. You don't see the pillars, but they are the pillars, many of them, which were probably 9 meters deep. And that's a concrete slab for the base. That's May 2001. Each year in the studio, we try to make a trip, not only to design, but to be on site. And in my opinion, it's important for you to go on site to test, and not only to draw, not only to read. Because then you see, you learn what you have drawn, and you really, experience that, right? So a few images from the building process. So the building, like a building site, it's always the same. In the beginning, it goes very, very quickly. This round thing turned out to be a little bit problematic, even at that scale. So every time you design something which is not straight, think about this twice before you do it, because at some time it's a problem. Also, the problem with that building was that it wasn't straight, it was twisted, and the roof is going up, which means that each of these wooden beams were meant to be on different level. That caused several problems. Well, in that scale, it's not a problem, but from my experience, we're a small studio, we're not doing big projects. That was a kind of challenge, right? So as you can see, this is the progress on site, and the metal cladding which covers the roof. And you very often face a problem with modeling, right? And in that, normally you can model in every software you want, but as long as it is straight, okay, easy. If it's not straight, it's not easy. If it's not straight, but you are doing this not, at the class, you're doing it for real, and you need to get contact with structural engineers, then it's a problem. Because this was, normally we don't, but this was the first time we really had to model every single part of the steel structure just to meet joints and that, because it was so weird. And during the process, as you can see, this is the rooftop climbing. So that's a kind of, I would say, very nice experiment if you can compare the visual and the building during the building process. And this is the part of the exhibition space. Well, I could spend many time about explaining about that. They are progressing slowly. And as you can see, the sheep are eating the grass on the rubbish hill, which is covered with green. Slowly progressing. We have winter in Poland, hard winter sometimes, so there are some pictures from winter. And this is the wooden cladding, which covers that. And these are the most recent photos. This is going to be the exhibition space for children, right? And the main hall. So that was one of the first case studies. I still have 20 minutes. I'm going to show some other projects, showing the kind of eco approach. This building was designed for the municipal botanical garden in Zabrze, which is south of Poland, close to my city. And the thing is that the existing botanical garden is very old. It's more than 70 years old. And they had some kind of financing funds, so they needed a concept in 1 month. And this concept has been developed in 1 month because they needed any idea for submission. And as you can see, at the moment, it looks like that. We had very little time to propose a building. They need to exhibit plans and so on. Was a few times bigger. All the palm trees and the cactus trees and which is inside grown already, and there is no space. So this was the main concept, to make the new building bigger. And there were also educational issues for the buildings, because one of the funds provided were funding the buildings which provide not only exhibition space but also educational space. That's why we got to this idea. This building offers an extensive educational path and serves the needs for protecting and restoring biodiversity. Each time you design something, I really recommend to make a first sketch. Make a sketch, hand sketch, which expresses or show your idea of the building. Because then sometimes it's easier what you want to do, how do you want to communicate with your client, and how you want to show what is going on. The building itself, I would say, was not very complicated, but still not easy one, I would say. Well, in terms of eco solutions, the photovoltaic cells, easy, movable glass panels also, and you can see the green rooftops, also hives for bees, and there was an idea of burning biomass here to provide heating. Yeah. So these were the ideas, the eco ideas, architectural solutions. And if you design and if you work design, I definitely recommend now your software that is working with 3D model. I mean, 2-dimensional drawing is good for a first experience, but then I cannot imagine to work anymore with a 2D software. Now I'm working only with models. So and sometimes it's really easy to express and show what is happening inside. But as I mentioned before, this project has to be done very, very quickly because of the funding opportunity and so on. And this was the first attempt. That's how it looks like now. And that's how it would look in the future. What you see here is this black thing is the coal trace of the old plant. Because it's in Silesia, and all Silesia has many coal mines. That's why. So that was a kind of reference to the area where we designed. Also, it has it is a sign that it's a kind of botanical garden, right? So there is it's not a coincidence that we put that on the staircase elevation. So that's how it looks like now, and that's how it probably would look after rebuilding that. And one of a bit of the interior design. So the visitors, I don't know how about botanical gardens, probably you don't need them because you've got moisture, you've got high temperature. In Poland, that's not typical. And the palm trees are something, you know, not common, also cactus. And the educational path as well. So there are some eco solutions in the building and in the architecture, right? And the educational path would go on 2 stories. And this is a top view, top perspective view. Also, I still recommend work with models, try to do physical models. Each time you do it, you realize something, and it's not only 3D modeling that will solve the entire thing. And sometimes it's very good to make a model to convince your client, to convince your professor that you want to do this and that. It's better to show it in the model. Imagine there are clients, there are people who don't understand visualization. And the model is something he can touch, he can tear off, and that's something different, right? So that was the first approach for this project. They didn't get funding, but that's after 1 year, they got funding, and they wanted to redesign that. We had more time, which was much better. Then we started to work with gardeners, with people who maintain the entire site. And if you design a building, each time try to talk to your client, talk to the user, and try to listen to the needs of the user. Because then, now that they need reclimbing zones, they need different lighting, they need different that. We had time for that. We had time to discuss. So we make another project. This is the site this is the back of the existing building. So because of the sunlight, they wanted to have the entire building around, not with the main entrance from this side. So the first idea was to get such a building, and imagine it's not pitched roof anymore because it turned out to be very expensive. And if you put the visual into the site, is also something that I really recommend. Try to Photoshop your building and paste it into the site. It's always very promising and important. It would probably look like that. But as I mentioned before, the building was slightly different. So the cafe was on the left. We still wanted to have this gray imprints of the old nature plants, which sometimes you find in the coal mines. But the entire building was different. Why it was different? Because that's not that expensive as the pitch roof before. This structure here could be used for tomato plant, right? It's much easier. It's a modular thing. You can extend it. You can make it bigger. And one of the ideas was to form such a building that could be extended in the future. If you use modular things, that is much easier. So that was one of the advantages, because the needs are very big and the budget was tight. That's visual of interior design. So basically, you've got plants, and also educational path was designed there. Also with a kind of hang bridge. But as you can see, the top structure is something completely different to the thing we had before. Much less steel is being used for the structure. It's much lighter. There is more sunlight. And this is the plan with the main entrance, place, toilets, utilities, and the visiting center. And the main thing is the exhibition space, right? But at that point, they wanted to have 3 separate climate areas. One climate for that, one climate for cactus, And the third thing was for different plans, right? So that's also, it's not really architectural thing because we need just to separate that, but it's a matter of climate. And believe me that climate control for different areas is a hard task, but because it's 3 times more pipes, 3 times more engineering stuff. Now this is the top floor and the section. Elevation views and the perspective view. So as you can see, don't be, stick to one idea of a building, because the next year there might be an idea to making the same building for the same client completely different way. I have 2 more projects just to show you and explain. I think we've got 10 minutes more. And this has been developed. I don't know if it is a kind of eco-architecture, but it's a park. Park design of approximately 5 hectares in Sośnicowice, which is not far from me. And you can see there's a large pond here. There was no pond before. So this is the Gliwice city, and this is a very small, tiny, it's not even, it's a small, it's a little town. It's a little town with a few thousand inhabitants. As you can see, there are a few buildings, but in the origin, they had this municipal park, which was very, very small. What they did is, in the beginning, what they did, they had only park here with old paths and nothing else. And if you try to convince your client, if you try to convince your professor, something is good, maybe you can think it is even better. Maybe a professor can think it's not good, but you can convince him or her in one way. Show him, show this person, show your client before and after, right? Photoshop is very useful for that, but sometimes if somebody believes that this place can turn into this place, that's much more convincing than showing the visual of that and saying it will be very nice, right? Here, it was really easy because I can put the photos before and after, right, in different places. One of the important things, you're going to church on Saturday, right? Well, the church is something different, but this is the park. It's not the park, actually. This is the park before intervention. And what we find here was in a grass which was that high, what we found was the statue. And the statue is the statue of a Saint Nepomucen, who was one of the local patrons there. And the statue was covered with green, really old, abandoned. Nobody really knew that something like that is. What we decided, okay, we leave the statue where it is. But on that place, we decided to make a pond. Why? Because there was a problem with water, and there was a kind of a swamp there. Normally, people wouldn't go. During the building site here, I had an opportunity to walk on the bottom of the pond. That was one of the, I don't know if anyone of you have been walking on the bottom of the pond, but it was winter, minus 15 degrees, and it was full of ice, no water yet, because it was the building site, so you could actually walk down there. But this is the same picture. During the building site, before there was grass, you wouldn't really go there. It was impossible to go there. The swamp was so problematic that the machine, the digging machine, started to, go deep. They had to pull it out. That was a problem. And some of the views before, after, right? So if you don't If you don't, you're not sure if your design is going to be good, then try to show before, after, use the Photoshop, use visuals, just to just to convince somebody that's your idea as well. And before, after, there were many trees. On that area, we decided to make some paths with different greenery and so on. Well, this is the description that the project involves the development of a small park and recreation center. And it is close to the city center of that city, and it is close to the school, which is important because the children from the school use those paths. And one of the problems was that this city didn't get much budget. We did the entire project for 5 hectares. We were ready with the project. And what they said, they told us, okay, but we are submitting for 7 different financial supports. Please give me the same project divided into 7. And that was really a nightmare because we had to, cut the path here and say, this is phase A, this is phase B, yeah? Etap is a phase in Polish, phase 1 and so on. So they were doing different phases from different financing, and they managed it because they are really great. So different phases, different scales, different documentation, different budget. That's much more complicated. So the conclusion is, every time you work, ask your clients if he's going to build in several phases, right? There's a problem. We also design a skate park, which has been built, and a place to grill and place to make sports on a part. In general, the entire park, and this is the phase 5. So this is this here is a pond design, and some drawings and some photos of the image, how it looks like now. Before, it was all covered with grass. The pond was really challenging. So if you design a pond, I've never designed a pond before, and it was a challenge because of the formal things. I don't know how about Turkey, but in Poland, if you want to do something with water, you need special permissions with the water agencies and so on. It wasn't really easy. For example, one of the questions was, if we can do the stones inside, we wanted to do this. I think it's nice. And what the client said, don't do that, because children would go and would sing, and you cannot provide it. I said, okay, put an information here. Don't walk on that, yeah. And it happened, yeah. So that's the design of the ponds in technical drawings, yeah. And sometimes it is, this was for the first time for me. That's why I think it was challenging. And this is how it works now. Probably there's too much greenery because there is not so much water. There was many problems with water coming out from here, coming out from there, and so on. And being an architect means that your work is probably endless. Imagine this project has been designed in 2016, 2017, realized in 2017, 2018, and the last phase was done probably in 2020, which means you are involved in a project more or less for 5 years, right? And one of the views. Now, the question is, if we finish, or you want one more case study? Go. Okay, go. This is the last bit. It can be called Echo. I don't know if it's Echo, but it hasn't been built. But this is housing estate. And this is the urban architectural urban concept for development of one of the sites in the city next to Gliwice. And one of the ideas of making this echo. So the project calls for the development of an area of about 3.5 hectares, and 20% of that was designated to park. 30% of that was dedicated to biologically active area. So, which means no paving, no nothing, as much green as you can do. Yeah. So the aim was to make 70% of the area permeable, which was really hard. And this investment couldn't be really extra expensive. So it cannot be Bosco Verticale from Milan. It's not that level. That should be, you know, more or less average estate. Yeah. So the project demonstrates the possibilities of such land use, which can be considered sustainable. I'm not saying it's sustainable. I'm not saying that's very eco, but so on. Okay. We got to the density of 66 units per hectare, with the height of the buildings from 4 to 6 stories. That is the site. That is the Silesian metropolis. And this is one of the cities on the side. And that's the last vacant area, which is 3 hectares big. You've got mosque, we've got church, there's a school here. And this is the project. In Turkey also, but in Poland, when you design housing estate, you always have to focus on parking. Car parking is very important. No car parking, no possibility to build a flat. And this is the site. And this is the project. So the first idea was that, I don't know, 20 or 25% of that would be designated only for public park. That was the first thing. So that is the park design here. Now, this part was designed to be implemented for development, right? Every time you design something in more urban scale, try to think about connections. As you can see here, there's a existing path and many people would go there, and we decided to keep that. And as you can see, this is a kind of before after visual. So this is before, this is the church here, and this is the path with a bicycle path we decided to keep, right? Also from that side, that was the proposal of the development. We decided that part of that will have commercial use in the ground floor. In Turkey, most of the building has commercial use in the ground floor, in Poland not. And one of the most important things is the park area. So I'm very happy with that we were able to design something green, really green, with water, drainage water reservoir, which collects water actually. So that was something nice, hill forest and vegetation areas. Now, one of the important things is bicycle paths. I know that in Istanbul, there are already some areas with bicycle paths now, not everywhere, but designing a bicycle path is meaning finding space for that, and that's always a challenge, right? This is the diagram showing the retention ponds for water and for drainage. We have we're starting to have problems with water because at some points there's so much rain you can't really manage in one moment with all that water. So the idea of retention on site, making holes, making store channels is starting to grow. Yeah. Usually we cut the grass. Now we are starting not to cut the grass, not to get the heat island, to get more moisture in the same place and so on. And inside there was an area designated for children with no car movement here. So no cars could access the interior. And that's something what I really like. So part of the roads should be permeable. So it's not really comfortable for your shoes, especially for ladies. If you go on the hills, it's not good because there are holes in that. But that's the only way to provide getting more moisture. Yeah. And some visuals showing how it looks like with cafes and commercial views from the part of the church. Normally in Poland, after the mass on Sunday, people would go, to get some sweets, to go to cafe. And that's the entire area. So we also decided to make the building slightly different in terms of height. So one building is 4 stories high, the others are 6 stories high. And we got really, really big car parkings, undercroft car parkings. And what we wanted to do is to get some green rooftops, just to manage better with stormwater and with water. Yeah. Also, we propose steel gratings for greenery to grow and a small cafe in between. As you can see, the entrance to the garages take a lot of place, and there were many of them. And so if we want to get to the detail, there are here detailed plans, but I'm not going deep into that. We have decided to make a building that has 4 to 5 flats per floor. I'm not going to explain about the layouts. I would say it's quite typical housing, which we're doing now in Poland, and elevation views, visuals, different types of buildings, different types of flats. Yeah. And the total view. As you can see, the car parking, sometimes it's even more complicated than designing flats, with entrances, with circulation, and so on. And as I mentioned before, always try to work with model, right? Discussing with the client during the discussion, we were really tearing up 1 floor less, 1 floor more. That's something you can really operate. You cannot do that directly, very quickly in 3D. Yeah. That's it. So if you've got any comments, questions. Yeah.
My question is,
Can you get one of these so that we can get the those who are too?
this is my.
No, the microphone on the camera, so it goes into it, because some people are not here.
So my question is about the rooftops.
Since it's an ecological building, especially the first project that you had showed, in that one, what is the roof material? In the second one, it was clear that the roof material was steel.
Yeah.
But the first one, I'm not clear about what the roof material is like, or even in this one.
Well, in that case, the housing estate, that's concrete. Concrete, then you've got insulation, then you've got the greenery layers. Yeah. With the first project, that was slightly different because we used folded steel in terms of structure, then you put insulation, then you put vegetation layers. Right?
Okay.
Anyone else?
Thank you.
I have a few comments.
Yeah, yes, please.
Echo. Maybe you want to turn off your microphone there.
My microphone, how to do now? You mean in Zoom?
In Zoom, yes. Mute yourself, which I can do myself. Alt and. Okay. No. So as you know, the heading of our studio is Sustainable Community Center in Fener, right? So we have placed the word sustainable in the assignment because Uzak University believed that sustainability is one of the most important items in the agenda today in the field of architecture and in general as well. Our campus has the Green LEED certificate, so it was designed following sustainability criteria, having photovoltaic panels on the roof, recycled garbage collection and processing in campus, and so on and forth, right? Nature, landscaping, and many other items. So we have seen today a very good example of some applications of sustainability, let's say, to the overall design process. So let's say one part of it is green, right? Having plants, but not plants, designing those plants so that they are part of the overall composition as a landscape architect or a landscape artist. It would be better, in my opinion, if that is integrated within the design process, not that you are doing the box and then you call somebody else to do the greenwashing and put the plants there. It's part of the overall design as a whole. But the other thing I want to outline here is how do we measure sustainability? Does anyone know? How can I measure how much a building is sustainable? Exactly, how much energy it is needed to build that construction. But I would also add to maintain the construction, because the construction process could take 1 month, 6 months, perhaps 1 year, but the maintenance of the building is 10, 20, 30, 50 years. So in summarizing, it's 1 to 10, the amount of energy that you're consuming for the construction process compared to in general, okay, the amount of energy that you're consuming to run the building in time, it's 1 to 10. So I'm not saying that you should not, design sustainable buildings. Yes, of course you should, but you should design buildings whose entire life is going to be sustainable. In terms of waste processing, moreover, above all, in terms of energy consumption. Because that is the big part, the big slice of the cake is energy consumption. So heating, cooling, water treatment, all the energy that goes in the building. If you take it from the grid, you're going to burn carbon or petrol or something else to produce that energy. So is that sustainable? If you compare that amount of energy that you use in this building in 1 year, the computers, the projectors, the heating, the air treatment, all that, I think it's more than 100 times the amount of energy that was used to produce the building itself. So that part is very important, okay? How much energy is going to be needed to run the building throughout his life? That amount of energy sometimes is converted into CO2 emission. How much CO2 kilograms or liters or whatever are we emitting in the atmosphere to produce that amount of energy? But anyhow, you can measure it in CO2 emitted in kilojoule, in I don't know what else. You can measure it in money as well. Now, for a building, the biggest part of that is the climate treatment and illumination, right? So when you design a building that has glass everywhere in Istanbul, in summer, 40 degrees, you're going to be spending a lot of money for the climate treatment. Is that sustainable? No, it's not. If that's the summer problem. As for the winter, we got the same issue because we're heating the building, and to do that, we consume energy, we produce CO2. That is slightly more complicated, how you can minimize the energy consumption for heating the building. And the first part of it is making an properly insulated building so that there is no dispersion in the heat in the building itself. Again, big glass surfaces don't work this way. They do not insulate. So if you're spending $100 to heat a room and you have glass everywhere, you're going to have to spend twice as much to keep that heat inside. So for now, I'm talking about the envelope of the building because this is what we mostly design and talk about, but there's more. Okay, there's the machinery you're using, there's where you take that energy from, you take it from the photovoltaic roof, water heating system with solar energy, or you can take geothermal energy from underground to heat the building. There are many different aspects to do this. You can use renewable energy to heat the building, and where wind, aeolic, photovoltaic, hydraulic, electrical power plants, but that's not part of the building. That's outside of the building. I would recommend to be very careful in your envelope design, the skin of the building, because that is the place where you have the heat transition from inside to outside. So, and I don't know about, I'm not sure how much percentage of the overall CO2 produced in the building's life is within this, but I think it's pretty much. I'm not sure if it's 80, 90, or 70, or 60, but it's for sure more than half. It's a lot, because every year of every day of the year, you're consuming some energy for the climate of the inside of the building. Another thing is illumination. So artificial illumination, you have to pay for it, right? Whereas natural illumination, you don't pay for. So that's something to keep in mind, even though it is not as much as the heating, right? But it's still there. So when you design classrooms with no windows, they're not on the right road, okay? That's not the thing to do. Also, if you design a room with no windows, not only there's no illumination, which is obvious, but I would like to recall, because many students, that there's no air change, right? Ventilation, proper ventilation, which is required by code. So it's not like a luxurious item we would like to design as aristocratic architects. No, it's required by codes about illumination, aeration, proper insulation of the entire surface, all the window, the whole package, the whole dress of the building is very important. There are many more other things. The other one is somebody's trying to get in. The other one is the self-sufficient, energetically self-sufficient of the building. Does the building need to collect energy from outside, or does it produce the energy it does need? That's Okay. So that's another thing. So if you need to buy the energy, you're paying for it, but also you're producing CO2 to produce that energy, and so you're not sustainable. So a building that does not have to take energy from the outside for his life altogether is more sustainable than one that has to take the energy from the electrical grid. And to do this, you need to put solar panels on top, right? And how many solar panels do you need to do this? That's a very key, important point to know, because there's a ratio more or less of 10 square meters per kilowatt. So kilowatt is the energy consumption, and 10 square meters. Maybe a little bit less, but that's the average, right? It depends on the efficiency of those panels, but it's not 1 meter per kilowatt, it's 10 or 11 or 12, depending also where you are in the world. But how many kilowatts does this building require? I don't know. I think several thousand. For you to know, an apartment, normal apartment, usually it's 3 kilowatts, something like that, 2.5, 3, sometimes 4. So to produce the energy that you need for one apartment, let's say 100 meters, you need 30 square meters of solar photovoltaic panels if these are properly designed, properly oriented, and they receive the sunlight all the time. So we can say that roughly speaking, 1/3 for residential of the surface of the residential unit is needed for the photovoltaic panels to make it sustainable. What does it mean? If you make more than 3 floors, the roof is not enough. So I'm trying to give you an order of greatness. Now, so designing sustainable architecture has to do with all these things. We have seen other items such as the biodiversity, the animals, the connection with nature. Natural ventilation is one other very important thing. So you can have the natural ventilation happening by heat convection, in the summer, so that you don't need, would be better if you don't have to use climatization devices, because those are very expensive, right? Anyhow, there are many different technologies that can be used to have natural heating, natural cooling in the winter. Traditional architecture in especially in the warm countries, has a very interesting list of examples of these things that are done in Iran, in Yemen, those warm countries, very warm countries, where vernacular or traditional building technology has in centuries brought up solutions, to have your natural cooling or heating system. Same is for the cold countries on the other side. So particular attention is to be given to these aspects, but let's not forget the building itself, as a collection of technologies and materials. Some materials are more sustainable, some are less sustainable. Those materials that are recycled or recyclable are eventually more sustainable. Even there, you can measure how much energy you need to produce that piece of brick, of steel, of timber. Or so just to recall that in our heading, we have sustainable. We would like to push you in producing sustainable solutions for design. That's my comment. Thank you. So thank you very much to Tomasz Bradecki for being here with us. I'm going to stop the recording and